Okay. I'm going to share my screen. Why? All these people are trying to join from outside of the ECC network. I don't know. Okay. I'm going to share my screen with you because I want to show you what this does when you put this in your calendar. Let's see. I'm just going to share my entire screen because when I share a window, things go wrong. Okay. Yes. Share. Okay. So there you guys are. And I would like to show you my calendar. So when you accept the invite, what it's going to do is it's going to put our class on your calendar. Yours might be set to day. I keep mine set to month. I just like to see the whole month. But notice that when you click on the actual class in your calendar, it gives you an option to join with Google Meet. So you don't have to find the link, or I don't know, maybe you guys bookmarked the link. It should be the same link every time. But if you just click this from your student Gmail, then you will be coming in through the ECC network into our Google Meet. So mostly I just wanted to show you how cool that was. I also wanted to show you in the calendar how the recording for our meetings actually gets logged for that day. So remember on Monday, we were talking about the syllabus and I showed you some things on my math lab. Well, I recorded the session and I did put a link on YouTube. However, as soon as class is over, it does not take very long for Google to compile a video of the meeting. So when I actually go to click on the meeting that we had on Monday, it has a transcript of the chat. So anything that, any questions that were asked in the chat, you could see, which I don't know, maybe you wouldn't find that helpful, but you can also watch the video. This is the MP4. So you can access that straight through your calendar without having to worry about finding a YouTube link to see the class session. So that's one of the things I really like about actually just putting this in your calendar so that you have it. So I just wanted to show you that. Now I will stop sharing my screen, stop presenting. Does anybody have questions on the calendar? Good, we're up to 27 now. All right, any general questions before we start getting into chapter 1? Okay, good. I love that I can see your faces and I can see that you're doing this, telling me you don't have any questions. And even though I see only a small representative sample of you, at least it gives me something. So like I said, I can't force you to keep your cameras on. I do find it really helpful if you do keep it on. I know that doing an online class is new to a lot of you and you feel weird asking questions and it's kind of hard to understand, like, can she hear me? If I ask a question, is it awkward? If you just want to ask a question in the chat, I'll try to look at it. Okay. And that's fine. If you just want to speak up though, usually since everybody's muted, when somebody unmutes, I can hear. There's like a little bit of feedback that I hear. So that usually prompts me to know that someone has a question. So then it's not quite as awkward where you're like, excuse me, can you hear me? Because usually I'll hear somebody click off when they unmute. But I can't see all of you, but you're gonna have to speak up if you do have a question on any of the material or anything else. I will try to make sure I stop and give you guys lots of chances to ask questions in case you have them. Let's see, did I want to say anything else? Oh, some of you guys were emailing me about homework assignments. Whatever I assign today is due Monday. So anything that is assigned will always be due the Monday after it's assigned. So anything I assign 1 week on Monday or Wednesday is due the following Monday. And the due date will be on my math lab. I saw that maybe like 1/3 of you were already on my math lab in our course, which is great. I did put up some orientation questions already for you, and then I'm going to add some more stuff from chapter 1 in there tonight. Now, remember, if you don't have the money to sign up for my math lab right now, you have a 14-day trial period that you can use. So if that's what you're waiting for, don't keep waiting to start doing the homework. You don't want to fall behind. Use the 14-day trial period. It gives you a little bit more time to get your actual account going, so you can at least get started on what we're doing. Okay, Any other questions about my math lab or homework or anything else?
I have a question on the notes.
Yes.
I only see, I don't know if you, like, they're supposed to be in order, but I only see 1.1 and then it goes, and then I have like a random 1.5 page and then 2.1, 2.2, and 2.4.
Yes.
And 2.5, is that correct?
Yes. So we're not actually covering 1, 2, 1, 3, or 1, 4. We're doing 1.1, and we're not even doing the whole section. We're just doing a small part of 1.1, and then we'll be doing 1.5. So I don't even remember what's in the rest of chapter 1. It's something where if you wanted to go through it, a lot of it is stuff that we're going to be doing as we work through 1.5. Especially this stuff in 1.4 with complex numbers. So if you really struggle with the complex numbers stuff that we do in 1.5, you might want to go back to 1.4. But technically 1.5 is still even review. So yes, so the notes you should have, if you got the notes I sent in the mail, and I know our roster has changed a lot since then, 1.1, 1.5, 2.1, 2.2, 2.4, and 2.5. We're not doing 2.3. That's an optional section for our course. And then someone else had asked me about the rest of the notes. Tonight, I'm going to submit to the copy center, and I wanted to wait till tonight because I know that our roster is so fluid, but I'm going to submit for copying and for mailing the rest of the notes for the class. There's a 2-week turnaround time on that. So the notes that I'm going to submit for copying and mailing are going to be from 2/6 through basically the end of the course. I don't know if the copy center is going to want to wring my neck after they get that. I don't know if that's something that a lot of teachers are doing, but I know a lot of people don't have printers of their own. So I want to make sure you guys have copies of those. But I hope that you'll have them by the time we start 2/6 in 2 weeks. I'm assuming if I send it tonight that you will. So that's what you can expect. Okay, so good question. Anything else? So I noticed also that since it gets dark earlier now, by the time our class was over the other night, it was basically just like this extremely dark photo of like me. So I'm going to try to remember that because I know it helps if you can see a face. I didn't realize how dark it had gotten, and it was just like this shadow trying to talk to you. So I tried to open some curtains to let in some light. So I'll try to remember that. Okay, so let's start with section 1.1. which is basically just sort of talking about your graphing calculator screen output and how to interpret it. I don't know how much experience you guys have with using your graphing calculator, or at least the calculator or the graphing portion of it. You probably use it just for minor computations if you have already had it for a while. But what you're seeing in the 1.1 notes, and I'm very sorry if you didn't get them through the mail. I only could send them to the people who I had on the roster at the time. You can either print them on your own or get someone else to print them for you, or I'm going to be posting mine when we're done. Let me actually share my window with you because I'm going to be putting my notes up here. I'm trying to keep this class as similar to an in-person class as possible. And what I would normally be doing in class is I'd be standing up at the Almo going through these notes with you. So I'm just doing the same thing except on the computer. All right, let's see. So I will be putting these notes, I'll be scanning them in and posting them to D2L. And I'm not going to be doing that all the time, but at least until you guys get all of the copies of your notes, I'm going to do that just because I know that not all of you have a printer. You might not have the notes. If you want to do it on your own paper, that's fine. But the thing with college algebra is there's a lot of graphing involved. And I don't usually do guided notes for every class. But because there's so much graphing involved in college algebra, I found it to be easier to use guided notes because I was sitting there waiting forever for students to copy things down off of my notes. But you're more than welcome to just use paper and do your own notes if you want to do it that way. Just is going to take a little bit more time. But I will be posting these. All right, so this is section 1.1, graphs and graphing utilities. Notice that there are a bunch of objectives in 1.1, and we're only going to be doing the interpret information about a graphing utilities viewing rectangle or table. That's really the takeaway here. We are going to be using our graphing calculators quite a bit, and we're going to need to make sure that we can interpret what you see in the graphing calculator table. So everybody can see my notes, right? Okay, good. Wonderful. Okay. Let's talk a little bit about the scale. A lot of times when we graph something, for instance, we might have some huge polynomial function that, I don't know, maybe it goes out really far, and maybe it doesn't do its little squiggle in the middle until you're way up off of the x-axis. And sometimes you're going to graph something, and then when you actually look at the graphing screen, it's going to look like there's nothing there. Sometimes you're going to have to fix your viewing dimensions. Or you might be looking at something and all of the data might be really smashed into this small section, and you want to expand it out so that you can get an idea of maybe where the maximum and minimum occur, or where some points of inflection occur. And in order to do that, you're going to have to be able to work with your viewing window. So what this exercise starts doing in 1.1 is talking about how to read the dimensions of a viewing window. So you are given here basically just a blank view of a calculator output, and you're being asked to find the correct viewing rectangle dimensions that are in the figure. Now, when you're looking at these options for A, B, C, and D, what you're looking at here are just basically the standard way that we would note the dimensions for a graphing calculator window. If you would like to write down just sort of a key for what this means, basically you're looking first at the x minimum value up to the x maximum value, and then we're going to look at the scale. And then we're going to take that to the y value. So we're going to look at the y minimum value, the y maximum value, and the scale. Is my handwriting big enough for you to see? I don't want to have it so squished. Okay, awesome. All right, so the scale is basically just talking about how many units are in each tick mark. So looking at your options here, if your scale was 10, that would mean that each one of these tick marks represented 10 units. Now, if that was the case, and you could just start by looking at one dimension, let's maybe look at what's happening on the x-axis. You would know that after 1 tick mark, 2 tick marks, 3, 4, 5 tick marks, if each one of those tick marks represented 10 units, then you would be talking about 50 units on the x-axis as you work your way from the origin to the edge. Now, if that was the case, this number would not be correct. It's not 25, it wouldn't be. That's how you know that A is not your solution here. It can't be, because if each one of your tick marks represents 10, well, then the x-axis max would not be 25, it would be 50. So you can kind of go through each one of these multiple choice options by using this sort of thinking. Just trying to figure out what it can't be, and then just eventually you're finding a solution that works. And you can do the same thing for B. So if each one of these tick marks represented 5 units, now we can look at this on the y-axis instead. Well, that means that the y-axis would go up to 5, 10, 15, 20, 25. Well, that looks good. But then if we talk about the minimum value for y, we would go down 5, or -5, -10, -15, -20, -25. So that can't be -50. The y minimum value would have to be the same as the y maximum value. And for this particular dimension that you're given in B, that's not the case. So we could say that B can't possibly be the correct viewing rectangle. Now I see I have some chat entries. I want to check them. Okay. That question I will get back to. Excellent. If you have a question about the Google Calendar thing, let's talk about it later because it is helpful. Okay. Looking at C then, I'm talking again about having 5 units per tick mark. So remember that the y-axis is represented by this second set of dimensions. So we already said that if we went up 5, 10, 15, 20, 25, that the y maximum value would work. And we already talked about the fact that the y minimum value would be negative 25. So the second dimension is good. Now we'll just check the first one and make sure that it checks out. And if it does, then C will be the correct option. So again, we're talking about having 5 units per tick mark. Now we're looking at the x-axis because that is what is representing the first dimension. So 5, 10, 15, 20, 25 is your x max. And then -5, -10, -15, -20, -25 for your x min. So it is indeed C. And you kind of get used to doing these. You'll have like, I don't know, maybe 2 of these on your homework so that you can get a little bit of practice with them. There aren't a whole ton of questions from 1-1. But that's really how you use these viewing rectangle dimensions that you're seeing in your calculator. And your book is going to show them whenever it's showing graphs. The same with your homework. If you're not looking at the book, the My Math Lab problems are going to give you viewing dimensions also whenever you're looking at a graph. All right, any questions about number 1? Ben wants to know if the scale for D was 1, would it be correct? That's a great question. And yes, if that is the case, yes. If for D you had a scale of 1, then you would have that every tick mark represented 1 unit, and then you would have the x-axis going from -5 to +5. And the y-axis would also be going from -5 to +5. So yes, if scale was 1, D would also be correct. Yeah, so that's a really good question. And you could even think about, you know, other possibilities for A and B, like how could we make that work? What would the scale have to be? That sort of thing. And with A, it's a little bit easier to see how it relates to C, you know, if you drop the scale down to 5 instead of 10. Okay, good question. Any other questions on number 1? Okay. Number 2, very similar. This time, you do not have a graph that is centered at the origin. It's moved around a little bit. You guys take a second and look at these and see what you think before I go over it. Now, the nice thing about number 2 is that in every single one of these cases, the scale is 1. So that makes it a little bit easier to figure out what the viewing dimensions are. And I have someone volunteering that it is D. What do you guys think? Is it D? Well, if it's not, we can quickly rule it out. I would definitely say no to A, because you do not have the y-axis going from -1 to 8.
I have a question. I don't know if I
Yes.
should. Well, my question was, When you're on the actual calculator and you want to see this actual, what would you call it, like graph, would you look at those numbers and see it?
Hold on, Karen. You're a little muffled.
Let's say I wanna, let's say I wanna get this graph number one on my calculator, the graph we did on number one.
Mhm.
Since the answer was C, would I insert like negative 25, comma 25, comma
Yeah,
5?
actually, that's a really great question. Let's finish number 2, and then we'll look at how to do these on our calculator. That's a great question. Yeah. You mean you just want to know how would you get this to show up on your TI?
Yeah.
Yeah. Let's do that. Let's answer this one, and then we'll do both of them.
Okay.
So you can see. Okay. All right, so A is no good because X does not go from -1 to 8. X does, but Y does not. Y clearly is not moving from -1 to 8, so A is no good. Now for B, and remember this one's easier because the scale is always 1. B is saying that X goes from -4 to 5. That's not true, does not. C is saying that X goes from -10 to 5. No. So you don't even need to look at what's happening with Y if you can see what's happening with X and you can see that it's not the case. Now D has to be true by process of elimination, but D says that X is going from -1 to 8, and you can verify by counting your ticks, 1, 2, 3, 4, 5, 6, 7, 8. And then it's saying that Y goes from -4 up to 5. So -1, -2, -3, -4, and then 1, 2, 3, 4, 5. So D is the correct option. I want to look at this in the graphing calculator. I'm going to put my screen up. Before I do that, does anybody have a question about that? Okay. See what kind of crazy stuff is on my calculator. I actually have not used it, and this is probably the longest I've gone without using my TI. With my summer class being canceled, that was the first time I didn't work during the summer in like 10 years. It was very bizarre. I had to figure out what do you guys usually do in the summer? What happens when I'm not working 4 nights a week? It was very weird. But here we are. Okay, so to get these viewing dimensions, let's do the ones for number 1. We have a graph that's going from -25 to 25 using a scale of 5. So what you're going to do is go to your window, which is this button right here. Now, you could technically create this graph. It would look the same, but it would have different dimensions on it. But if we wanted to exactly match what we see here, we're going to change the scale to 5. And you can change the scale here. So X scale and then Y scale, you would change each of those to 5. And then your X min and your X max would have to be -25 and +25. And you would do that for both of them. Now, we don't actually have a function that we're graphing in here, but we should still be able to see this pop up on our window. I'm going to go ahead and say graph, and you'll notice that the output that you get in your calculator looks nearly identical to what you're seeing on the sheet. If we were to put a function on there, you'd be able to really see those numbers, because you're not going to see, it's not going to list out that you're going up to 25. So on and so forth, but that's the way it's going to look. If you wanted to do the same thing with number 2, the scale would have to go back to 1 again. So again, you'd go to your window, this time switch the scale over to 1 in both cases. The X min is -1 and the X max is 8. And the Y min is -4. And the Y max is +5. So yeah, so that's how you use your window. We're going to be using the graphing calculator quite a bit, especially once we get into chapter 3. And then we'll be using it for other types of applications when we talk about matrices and solving systems of equations in chapter 6. So we'll be using this a lot more. Okay, any other questions? I have no idea who this person is.
Yeah, I had one question.
Oh, go ahead. Yes.
So you said for the TI-84, does the Nspire still work, or do I need like a TI-84, 83?
Some teachers say you can't use the Nspire. As long as it doesn't have CAS, technically you can use it. Because we're online, I can't verify whether or not you have that. So that's sort of a limitation that I have with you guys being online. So you can still do this on the Nspire. Is your question more related to how you would do this?
No, I was just like, if it would be able to be possible, like.
Oh, yes, you should still be able to do this on your Nspire. I do have an Nspire around here, and one semester I had so many students who had Nspires that I just started showing everything 2 ways, but now it seems like a lot of students aren't using them as much. But if there's a question you have specifically about the Nspire, stick around for the office hour and we'll work on how to do it.
Okay, thank you.
You're welcome. Anyone else? Questions here? All right. The other thing I want to do here is just interpret information out of a graphing calculator table. So what you're seeing here with this table of values is you actually had 2 different functions that were being graphed. One of the functions was y1 and the other function was y2. Remember that a function sort of works like a machine. You have an input that's going into the function, and then the y value is the output. So when you graph things, I guess I'll just kind of pop that up here. Anytime you're graphing in your calculator, normally you're just graphing one function, and that would just be entered as y1. But if you're graphing another function, then you'll get values in your table for y2. So let's see, there's really no function to show you, so I'll leave it at that for now. All right, so you're being asked to use the following table to answer these questions. So question 3 is, which equation corresponds to y sub 2 in the table? Now, keeping in mind the fact that x represents your input and y represents the output, you're trying to figure out which one of these equations corresponds to the data. So you're going to have to just test them out and see which one gives you values that work. Now, if you find one value that works, that does not mean that it is the equation. You need to make sure it works with all of the values in your table. But we're looking at specifically y sub 2. So what we're going to do is we're going to take the values for x and y sub 2, and we're going to plug them into these equations. And we're going to figure out which one of these equations is true for all of the values that show up in the table. So if I was checking A, for instance, I'm looking at y sub 2, and I'm just going to start with the first row. Y sub 2 is -3 equals 3 minus 2x. Now remember, it's 2x. That's implied that it's 2 times x. So we're going to use multiplication here. The corresponding x value is also -3. Now the goal here is, if you immediately find that this is not true, then you can get rid of the option A and move on and find one that does work. So we're going to simplify on the right-hand side. 3 plus 6, remember minus and negative just gives you a plus, or this is really just 3 minus -6. Clearly, this is not the case. -3 does not equal 9. So we know that A cannot be the option that we're going to go with. So we're going to also try B. Does anyone have a question about how we did that for A or why we excluded A? All right, so let's try B. I mean, you can try C first if you want. I'm going to go with B. So for B, we have y sub 2. And again, I'll just start by taking the first row out of the table. Y sub 2 is negative 3. And we're going to see if that's equal to 2 times x, which coincidentally is also negative 3, plus 3. So that is the definition of B. Now, once we substitute the values, we're going to simplify and see if it's true. 2 times negative 3 is negative 6. And when you add 3, you end up with negative 3 is equal to negative 3. Now, that's true. That does not mean that you automatically put a circle around B and say that it's the solution. You have to make sure that it's true for all values. Now, I don't think you should have to sit there and test every single line in the table. As long as you check 3 or 4 of them, or even just check 2 of them, and then go over to C and D and make sure that they're not true, that's fine. And when you're doing your homework, it's up to you. I can't make you verify any values, but just make sure that this is also true for at least one more set of values from the table. So we used B. B looks really promising. Let's use it again, but with another row from the table. I should really expand this out because I'm clearly running out of space here. Maybe I'll do it down here where we have more room. Okay, so I'm using B, and this time I'm going to use the second row in the table. And the second row in the table is x equals negative 2, y sub 2 equals negative 1. So y sub 2 is negative 1, x is negative 2, and I'm going to verify that the equation is true. If it is, I'll probably just show that C and D are not true and call it a day. 2 times negative 2 is negative 4, plus 3 is indeed negative 1. You don't have to say negative 1 equals negative 1. Once it's really clear, you can stop. If you feel comfortable saying it worked for 2 values, it's probably going to work for all of them, that's fine. Put a circle around it. Sometimes students are really good at just looking at these mentally. So you could see that maybe if x and y sub 2 were both negative 3, you could use option C. Sorry, I should zoom out a little bit. C is y sub 2 equals x plus 3. So you would be saying negative 3 equals negative 3 plus 3. Not true. So already you've excluded C. And then you can work on excluding D. D was y sub 2 equals 3x minus 2. So plug in the values that you see in the first row. Clearly, these are not going to be equal. And we can exclude C, we can exclude D. So you're all going to have a different method for doing that, looking at the numbers, trying to figure out which option is the correct one. The question I'm seeing in chat is, are we allowed to do this with the tables in our calculators? That's a great question. You guys are asking a lot of calculator questions. I'm actually pretty happy about that. Yeah, technically, let's use our calculator to show this. So in order to do that, we can draw up a table of values, assuming that B is our equation. So maybe you looked at the first row and you said, I think it's B. I'm going to verify this using the table in my graphing calculator. Do that. Now, I know that technically this is labeled as y sub 2. If you're really picky about it and you want to put it in your calculator as y sub 2, that's fine. Do that. Maybe I will, just to kind of go with the flow. The equation for B is y sub 2 equals 2x plus 3. If you do not have a lot of familiarity with working with your graphing calculator, let me remind you of how to enter this. When you're entering the variable x, don't hit the alpha, the green alpha button, and then I think there's an X on here, I can't remember. Yeah, don't hit alpha and the store button. Hit the variable button, which is this one. Your graphing calculator is most likely in function mode. As long as you're in function mode, your variable button is going to pull up X. If you're in other modes, parametric mode, radian mode, I don't remember what that mode is, it'll pull up a different variable. You won't be using that anytime soon. So we have 2x plus 3. Now your table is probably set to auto. Let's go ahead and check what your table is set to. When we hit second window, that's going to get us to the table setup. Now mine is set to ask. Personally, I like it set to ask, but I'm going to set it to auto right now so that it will generate values that look like the ones that we have in the table. So I'm going to make it start, and I like how it's starting at -3 because that's where the table is starting here. I'm going to have it start at -3, and this delta table that's in your next row, that tells you, that's basically asking how much you want each value to increase by. In our table, each value as we move up in X values is increasing by 1. So delta table equals 1 is what we want. Sometimes you'll see them increase by 1/2, or you'll see them increase by 5s. Usually you'll want that set to 1. And then I'm going to set my independent variable to auto. Your dependent should always be set to auto, but independent, depending on what you're looking for, you might want to switch back and forth. And then I'm going to go to the table. So to go to the table, I'm going to hit second, graph, and that's going to get me to my table. Now, note that we're going to see the exact same values in our table on the calculator as we saw here on our sheet. So we have -3, -3, -2, -1, -1, 1, so on and so forth. All of these values are the same. And because all of these values are the same, we know for sure that the function that we entered, 2x plus 3, is indeed the correct function, or the correct equation, I would say. So I'm really glad you asked that. Any other questions about figuring out which equation corresponds to the data in the table, or how we would use our calculator to do that? Okay, so yeah, usually students just test values, but if you want to use your calculator, be my guest. Okay, the next question, number 4, is does the graph of y sub 1 pass through the origin? That's a good question. Remember that the origin is this point on your graph. It is represented by the point 0, 0, which means x and y are both equal to 0. I'm going to remind you of that by writing it down on here. The origin, for some of you guys, maybe it's been a while since you had algebra, I'll remind you. The origin is the ordered pair 0, 0. So what you're looking at is you're going to look at the data for y sub 1, and you're going to see if the point 0, 0 lies on this line. That means when x is 0, sorry, let me get up here. When x is 0, y is 0. And from what I just said, that's true. If x is 0, y is 0. That means that the point 0, 0 is on the graph of y sub 1. So we would say yes, because x equals 0 when y sub 1 equals 0. So that's how we'll know that it goes through the origin. Okay, questions on number 4? Okay. The next question is, at which points do the graphs of y1 and y sub 2 intersect? Now, if your two graphs are intersecting at a point, think about what that must mean in terms of what's happening with the graph. I mean, you can just draw a little sketch to see what's happening. There's your coordinate grid. And let's say you have two graphs. I don't know what they look like. Oh, that's a 1. They could look like anything, but I don't know. Maybe you've got a graph that's doing that, and you've got one that's doing this. This would be the point where the two graphs intersect. What needs to be true when the graphs intersect is that they both go through the same point, whatever that point is. Let's call it x sub naught, y sub naught. That means each one of these graphs has to contain the point x sub naught, y sub naught. So what you're going to be doing to figure out if they intersect is determining, do they each contain the same point? So when you're trying to figure out, does each graph contain the same point, you're going to look at the table of values and determine if these two have the same y value for a given value of x. Now note that these two have the same value of y when x equals -1. That means it must be the case that your two graphs would have to intersect at the point -1, 1. So at which points do the graphs intersect? Well, they definitely intersect at -1, 1. When x is -1, y is 1, and that occurs on both graphs. There's one more place where that occurs, and that's here, where the values for y sub 1 and y sub 2 are again the same. This time the values are 9. So when x is 3, y is 9 for both graphs. So that means they also would intersect at 3, 9. And we know this because the y values are the same at these x values. And that actually leads me into the next question. The question is, for which values of x is y equal, or y sub 1 equal to y sub 2? Well, we already said that when x equals -1 and when x equals 3, we have the same y values. So that's really all we needed to cover from 1.1. It just kind of, you're going to get a small number of homework questions on it. There isn't a whole ton to do, but it's basically, can you interpret graphing calculator table readouts and dimensions for viewing rectangles? So nothing too crazy there, but it might be something that you haven't seen before. If you have questions about 1.1, I'll give you a second to ask them before we move on to 1.5.
Could you just go down? I just wanted to make sure because I missed for number 3, I got C and D that they didn't correspond. I just wanted to make sure if you got anything.
Correct, yeah. I mean, I only tried one value each for C and D,
Yeah.
and because neither one of them worked, they were done.
Okay.
They were no good. Okay. Any other questions on 1.1? Okay. I think now would actually be a really good time for me to run through the attendance real quick before I forget. So let me do that. I don't even know how many people we have now because some people are not on the roster suddenly. I don't know what's going on. All right. I'm not going to make you guys all say you're here. I'm just going to have to trust you. All right. So we have Ashley, Benjamin. We're going to start 1.5 next. So if you want to go ahead and get ready for that. We're going to be talking about solving quadratic equations. Brandon. So I guess this is a nice little break for you guys to relax. Karen, did you have a question?
No, I already asked. And also, the rest of 1.1 is we can recycle, right?
The rest of 1.1 is, what was the question?
We can recycle or we can throw away.
Is there more to 1.1?
Yeah, it's solve quadratic equations by completing.
Oh, that's 1.5.
Oh, I probably messed up my pages then. Okay,
Let's see.
I'll keep them.
I'll pop it up here so you guys can actually look at it while I'm doing this. 1.5. There we go. And maybe I'll zoom back in a little bit too. So if you are doing your own notes because you did not get a copy, then maybe you should start out by writing the standard form of a quadratic equation. My Google list is alphabetized by first name, and my roster is alphabetized by last name, which is why this is taking so long. Whoops. All right, let's see who I'm missing. Okay, Viviana. I don't see Viviana. Who else? Simon. Simon is new. I sent Simon a link, but I have not seen Simon. Check my mail. Okay. All right. Normally I get a new student and they just come into class, but now I have to remember to check the roster and send them a link or they can't get into class. So all kinds of challenges. All right. That was from today. Okay. Wonderful. So 1.5 is about quadratic equations. We are going to do a bunch of things here. Now, if you took Math 98 at ECC, then this was one of the last things you did in Math 98 was solving quadratic equations. This is definitely one of the last things I do with my 98 class. There's always stuff that I'm supposed to do after and I never have time for it. So this should be fresh for you if you recently took Math 98. However, for some of you who haven't seen this in a long time, it's all going to come back to you quickly, but you might need to pay a little bit closer attention. We're going to use a couple different methods to solve quadratic equations. Students always want to know, do I have to solve it a certain way? Yes. On your test, I'm going to specifically say, solve a quadratic equation, and I'm going to tell you the method that I want you to use. And then there will be some that I'll just say, solve it using your method of choice. So you do have to know how to use each method for at least one of each type on your exam. So if you don't like solving quadratic equations by completing the square, sorry, but I'm going to ask you to specifically do it, just so you know. So we're going to be using the square root property, completing the square, and the quadratic formula. We're also going to talk about the discriminant, which is going to tell you the number and type of solutions that a quadratic equation will have. Then we'll talk about maybe how to use the most efficient method. Sometimes you don't know and you just pick one. And then we're going to just solve one equation that would be modeled by a quadratic equation. A quadratic equation in X is an equation that can be written in the general form ax squared plus bx plus c equals 0. Now, some books call this standard form. Some books call it general form. Your book calls it general form. So that's what this is. A lot of times it's really helpful to have the equation set equal to 0, but it does not always have to present itself in this case. A, B, and C are going to be real numbers such that A is not equal to 0. If A is equal to 0, then you have a term where you have 0x squared. If you have 0x squared, then you don't even have an x squared term at all. And in that case, you would have a linear equation. It wouldn't be quadratic. So in order for it to be quadratic, it has to have some non-zero value of A. So A, B, and C are real numbers. A quadratic equation in X is also called a second degree polynomial equation in X. And we'll get into a lot of working with different degrees of polynomial equations. This one is a second degree. You might have talked about polynomials a long time ago. The degree of the equation is always just signified by the largest exponent that shows up on any one of your terms. So that's why you have a second degree equation. All right, so the first method that we're going to use is the square root property. Now, we're going to do the square root property first, and after that, we're going to solve equations by completing the square. We use the square root property when we already have an equation that's set up for us and that we have a quantity that's being squared equals a constant. There will be times when you already have something that lends itself to this form. If you don't, then we're going to use completing the square, and you're going to try to get something that's in one of these forms. But for now, let's talk about how to use this form. Quadratic equations of the form u squared equals d, where u is an algebraic expression and d is a non-zero real number, can be solved by the square root property. So this is saying that if you have some expression in X, u squared equals some constant d, some number, then u is equal to plus or minus the square root of d. So we can take the square root of both sides. The thing that students tend to forget here is when you're taking the square root of both sides of an equation, you must use a plus or minus sign because you actually have two different solutions here. Remember that if d is a constant, let's say d is a negative constant, a negative number multiplied by itself gives you a positive number. That's why we need to consider, oh, not d, I meant to say u. Excuse me. If u is some value and you square it, if u is negative, you still get a positive value to pop out. If it's positive, you get the same positive value. I mean, think about what happens when you square a negative number. -1 times -1 is +1. But 1 times 1 is also +1. That's why we must include this plus or minus sign on our equation. We have to signify that there are two possible values for the solution there. I'm going to show you how to use the square root property. We're going to make sure that we are in this form before we do any taking the square root on both sides business. So I want to have some quantity being squared equals a constant. Now, looking at number 1, you might think that, yes, we already have this form. We have some quantity being squared equals a constant. Well, you're close. Oh, sorry. Do I need to do like a... Sometimes I lose focus here. There we go. I never know. It's random. Okay. The 3 is not actually being squared on the left-hand side. Remember that 3x squared, I'm just going to make a small note up here. 3x squared does not equal 3x squared. The 3 is not being squared. And because the 3 is not being squared, that's not part of the squared quantity. That means that in order for us to solve this equation, we need to get rid of the quantity that isn't being squared. I just want the squared quantity equals a constant. In order to do that, remember that your squared quantity is being multiplied by 3. When we're solving an equation, when we want to undo multiplication, we're going to divide. So if you divide both sides of your equation by 3, then we can write a new equation. There we go. And the new equation would be x squared equals, and then 48 divided by 3 is 16. Now, some of you are looking at this and thinking, why do I even need to take the square root on both sides? I know what value I square to get 16, and that's fine. But that's also an instance where I would caution you to make sure that you're considering the negative value that you're going to square to get 16. So even though most of you look at this and you automatically see that, okay, if I take 4 and I square it, I'll get 16, so x must be 4, don't forget about negative 4. So that's what I would caution you to if you are not directly using the square root property. I'm going to show you how we do it using the property. It's like one step. It's very straightforward. What we have now looks like this. If I want to just get x by itself, I'm going to take the square root on each side of the equation. When I take the square root of x squared, I just get x. Once I take the square root on both sides, I have to apply plus or minus. Now, technically, this is equivalent to the correct answer, but you cannot leave your answer as plus or minus the square root of 16. My math lab is going to give you a canned feedback message that says something to the effect of, although your answer is equivalent to the correct answer, it's not written in the correct form. Please check the directions and check your answer. What that means is that technically your answer is right, but you didn't simplify it, or you didn't answer it in the way that you were told to do so. The directions are going to say, simplify your answer. You have to simplify it. So we're going to write this as x equals plus or minus 4. And then it's done. There is a plus or minus button on my math lab. However, on my math lab, you're not going to be entering your answers as x equals. Your book uses set notation to talk about solutions of equations. Whatever your book does, the My Math Lab problems for that book will do the same thing. On an exam, if I ask you to solve this problem and turn in your work by hand, and you give me this and you put a box around it, fine. I'm totally happy with x equals plus or minus 4. However, for my math lab, you're going to use set notation. Basically the same thing. I will show you what it looks like. So set notation for my math lab. Whenever you're solving equations, instead of having x equals and then an answer box, it's going to give you braces with an answer box. So you're just going to fill in the answer box. Most of the time in the symbol palette, there's a plus or minus button that you can use. And if you want to use plus or minus or then 4, that's fine. But you could also write your solution as -4 and 4. So you can write it as 2 distinct numbers, or you can use the plus or minus sign. Either one of these should be acceptable. So I want to make that clear. I didn't want you guys to get to your homework and be like, what the heck, where's the x equals? And sometimes students will try to put x equals into the set notation. The set notation does not use x. You just put whatever numbers you get for your answer here. Any questions on example 1? Okay. We're going to do something similar for example 2. It looks a little bit different, but it's going to use the same process. The reason that you will know right off the bat that you're going to use the square root property is because you have on the left-hand side a quantity being squared, and on the right-hand side you have a constant. Anytime that's the case, you're going to use the square root property. I have seen students in the past who have taken this left-hand side and they've FOILed it out and they've gotten 4x squared plus blah, 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 blah equals 16. They subtract 16 and they get something back in standard form, and then they use the quadratic equation. I mean, technically, however you get to the correct answer is fine, but this is set up for you to use the square root property. It's meant to be used with the square root property. So that's what I would suggest using here. Take the square root on both sides. Now, the difference between 1 and 2 is, in this case, you don't have anything else on the left-hand side. You don't have anything being multiplied. All you have is a quantity being squared. Over here, we had something multiplied by that quantity. Here, you don't have that. So let's go ahead. When we take the square root of a value that's being squared, we just get that value to pop out of the parentheses. And then again, we'll do plus or minus on the right-hand side and take the square root of 16. And no, you don't have to show me every single step. So if you wrote 2x plus 2 equals plus or minus 4, that's fine. Since we're using the square root property, I decided to show you the radical. Do you guys have any questions at this point?
At the beginning, I thought you could double it, like 2x plus 2 times 2x plus 2. That wouldn't work, right?
Well, that's kind of what I was saying that students want to do right off the bat when they see this. They want to square it out. So
Yeah.
you can, but as soon as you square it out, you're no longer using the square root property. You would have to use a different property at that point. And we will be using some of those properties later on in this section. To use the square root property, you want to keep the value squared.
Okay.
Does that make sense?
Yeah.
Okay.
Would you still get the same answer, though?
You will still get the same answer. This has fewer steps. So my guess is if you go through all the work of foiling this out, subtracting 16, and then solving it using another method, you leave more areas to run into mistakes.
Okay.
So this is easier, fewer steps, but there are many ways to solve quadratic equations. Any other questions here? All right. Wonderful. So let's simplify this because I also want to show you how not to leave this solution. So we have 2x plus 2 equals plus or minus 4. Now remember that we're trying to solve for x. So we're going to have to undo everything else and solve for x. Now it looks more just like a linear equation with this plus or minus situation going on. We're going to have to deal with that plus or minus in a minute. But for now, let's work on isolating x. In order to get x by itself, we're going to subtract 2 on both sides. Some of you guys may not have solved an equation in a long time, so I'm writing a few more steps than maybe I normally would. Now, it does not matter what order you put this addition and subtraction in, as long as the plus or minus stays in front of the 4 and that 2 stays negative, because when you moved it over, it became negative. And then we'll divide both sides by 2. Now, there are a lot of options at this point. If I were you, I would probably set up 2 equations, one of them using the plus sign, and another one using the minus sign. Personally, I think that would be the easiest way to solve this. Another option that you would have would just be dividing every term by 2. I tend to have students not do that because they forget to divide every term. So I think this is the easier way to go. So we have one equation that uses the plus and another equation that uses minus. Now we're going to continue to solve for x. Go ahead and simplify. -2 plus 4 is 2. -2 minus 4 is -6. And now you just need to divide by 2 on each side in both equations to get your values for x. So in the first equation, you get x equals 1. And in the second equation, you get x equals -3. Now, again, for me, I'm okay with you on a test saying x equals 1 and x equals -3. On my math lab, you're going to get braces, and you're just going to enter the values into the braces in either order. It does not matter if they are ascending or descending or anything like that. That's the set notation way to write your answer. Okay. questions there? Okay. The next one, I'm not going to have you guys try this on your own just because there's something different about this one that I'm going to need to remind you of. We're looking at x minus 6 quantity squared equals negative 6. So I'm going to remind you here of what to do when you get stuck on your radical. Notice, however, that this one starts out the exact same way the last one started out. You have a quantity that's being squared. There's nothing else over here that you need to get rid of or do anything with. And you have a constant on the right-hand side. That's another key here, having that constant on the right-hand side. That tells you you have a quadratic equation that you can solve using the square root property. So let's go ahead and take the square root on both sides. Take the square root on the left, and all you get is that quantity to pop out of that squared symbol. And then on the right-hand side, you're still taking plus or minus the square root of that constant on the right. But now that constant on the right happens to be negative. Back in your early days of algebra, if you were trying to take the square root of a negative number, you would say the answer is not real, X it out, I'm done, move on. However, you supposedly at the end of your intermediate algebra class learned how to use complex numbers. So you're expected to use those here. The square root of -1 is defined as I. If you don't remember that, I will put a special note on here. Recall that I is equal to the square root of -1. Now I'm going to split this up in 2 steps. You don't have to do that. I like to see your work, but I don't need to see every little tiny thing. A lot of times I show a lot of work just because I try to anticipate what questions I think you might have, and I try to answer them by including extra work. But that doesn't mean that everybody needs to show that much work. So don't feel like, oh my gosh, she's showing every little thing, I'm going to get points off. I like to see your work. You don't have to show me every little thing. But I'm going to show you how this works here. Keep the left-hand side the same. On the right-hand side, I'm going to split up this radical. I know that -6 is the product of -1 and 6. We have a property for radicals, which I'm also going to remind you about over here. The square root of A times the square root of B is equal to the square root of A times B. Now that works for multiplication. It does not work for addition. People try to get it to work for addition all the time. It does not work. It's not true. Sorry, I'm trying to get this to focus better. Okay, but it does work for multiplication. Since it's such a common mistake, I'm even going to put a note up here about it. The square root of A plus the square root of B does not equal the square root of A plus B. It only works for multiplication, does not work for addition. It's one of those most common math errors that teachers hand out to students and say, don't do this. Very, very common math error. Since I can split up a product, I'm going to split this up into the square root of 1 times the square root of +6. I'm sorry, not 1, -1. The square root of -1 multiplied by the square root of +6. And since I reminded you already that the square root of -1 is I, we're going to swap that out. We need to use I notation here. So we have plus or minus I times the square root of 6. Now, that was actually the hard part of this one. In order to get x by itself, the only thing we have left to do is add 6 to both sides of the equation. Now, remember that you can't add these two terms together and combine them. They're going to be separate terms. That's okay. Your solution is going to be 6, it's positive, plus or minus I times the square root of 6. I'm fine with this on a test. Again, in my math lab, you're going to have to leave this with set notation. The plus or minus button should be available to you. You could also leave it as 2 separate solutions. You have a lot of options here. And 2 separate solutions would look like that. Same exact thing, just saying it in a different way. Sometimes students also ask, can I leave the I term as the first term? Absolutely. This means the exact same thing as that. These two are equivalent expressions. You can always commute your terms when you're adding and subtracting. Okay, so a lot of review is going on here, especially with these complex numbers, which some of you guys probably haven't seen in a while. As long as we remember that I is equal to the square root of -1, we should be pretty good. Does anyone have a question on the square root property? Okay. I'm getting such good feedback from you guys, which I really appreciate, the visual feedback. And I also appreciate so many people leaving their cameras on. It's just really helpful to me. It's just so awkward trying to talk to a black screen, seeing no faces. Okay, now I have no idea. I keep, every year I'm like, oh gosh, I gotta go in there and fix that. But then I see that other things are fixed and I fix other stuff and I totally forget to fix that. It's very unfortunate. It's very blurry, so I'm gonna rewrite it for you so it looks really clear. If x squared plus bx is a binomial is a polynomial with 2 terms, 1 term, 2 terms. Then by adding half of b squared, which is the square of half the coefficient of x, a perfect square trinomial will result. That is, and this is so small, I'm going to attempt to make this bigger for you. X squared plus bx plus half of b squared minus x plus b over 2 squared. Oh, not minus, equals. Sorry, equals. What? Yeah, I'm going to make a big strong note on here to fix this. Fix. Back when you were in intermediate algebra, you learned how to factor perfect square trinomials. That's really what we're going to be doing here. We're going to be creating perfect square trinomials. We're going to do that by taking half of the coefficient of the middle term and squaring it. And we're going to add that to both sides of the equation. Now, when we do that, we're going to get a form that when factored looks like this. So the whole point of solving an equation by completing the square is we want to get our equation into a form where we can use the square root property on it. So we got really lucky on the first page. Everything was already given to us in a form where we basically just had to take the square root on both sides. That's not always going to be the case. So for these problems on this page, we're going to be completing the square. A lot of times, students don't like completing the square, but something amazing happens. They don't like doing it. They think it's hard. So they practice it and practice it and practice it, and then they get really good at it, and then they choose this method over any other method. It happens every semester. So even though at first you're going to be like, whoa, I don't like this, what's going on here? Practice it. Watch, you'll get really good at it, and it'll be really rewarding when you actually really get good at these. Let's first talk about finding that constant that needs to be added to both sides of the equation. We're going to come back to this formula in a couple minutes when we actually get to that point where we're factoring these perfect square trinomials. Determine the constant that should be added to the binomial so that it becomes a perfect square trinomial. Then we're going to write and factor the trinomial. So what we're doing here is note that we're being given a quantity that's a binomial, looks just like the x squared plus bx. This time we have an actual value for b. So b is 18. What we're going to do is determine the quantity that needs to be added to both sides. or maybe I shouldn't say added to both sides, to be added to make it a perfect square trinomial. So we're going to take the coefficient of x, which is going to be considered b. And this goes back to our definition for a quadratic equation in standard form, ax squared plus bx plus c. In this case, we just don't have a coefficient a. So we're going to take the coefficient for b and take half of it. Sorry, there was something that I used to do to this to make it focus really well, and I don't remember what it was. Okay. Once we take half of that quantity, we're going to square it. So we're always taking half of the coefficient of x and squaring it. Both of those things. Half of 18 is 9, and 9 squared is 81. So we're taking our binomial and we're turning it into a perfect square trinomial. Now, this is just an exercise to get us prepared for using this process in the next few examples to complete the square. So what we're going to do now is take our binomial, x squared plus 18x, and turn it into a perfect square trinomial by adding this constant onto it. Now, we don't actually have an equation here. Remember, an equation requires an equal sign. Right now, we have an expression. So we haven't really changed anything in an equation where we would have to do something to both sides because we don't have both sides. We only have an expression. So we have created a perfect square trinomial. Half of the middle term squared was added as the last term. Now we are going to factor our perfect square trinomial. And maybe I'll even label this as a perfect square trinomial. Okay. So going back to your definition that I rewrote for you up here so that you could see it a little bit more clearly, to factor your perfect square trinomial, you're going to use your variable that you originally had to the first power. We're going to square the whole quantity, so you're not really changing it at this point. We're just rewriting it. Then we're going to add on half of the middle term before we squared it. So that was 9. So that's where this part comes in. B over 2, in our case, was 9. And then we square the quantity. And that's how you factor a perfect square trinomial. And you could always check this. If you multiplied x plus 9 by x plus 9 and FOILed it out, you would get right back to here. X plus 9x plus 9x plus 9 times 9. If you don't remember how to FOIL, I'll give you a quick reminder right now. X plus 9 squared is x plus 9 multiplied by itself. So remember, you're taking the first, outside, inside, and last terms. And when you do that, you get x squared plus 18x plus 81. So it's kind of how you work back and forth. All right, so that's how you create a perfect square trinomial. That's how you factor it. Let's do that with another one for number 5. Before I do that, does anyone have a question on 4? Okay, wonderful. Am I getting super dark? I see some of you guys are getting super dark, like it's getting dark outside and there's no light coming in. Can't see myself. Well, I guess it doesn't really matter. I'm not too dark yet. Okay. All right, the next one. This one's a little bit trickier for number 5 because for number 5, we have a fraction as the coefficient of x, which is fine. We're going to do the same thing though here. We're going to take half of the coefficient of x. So the coefficient of x is 4/9. To take half of that, just multiply it by a half. Or you can think of it as multiplying the denominator by 2. But technically 4/9 divided by 2 is 4/9 times a half. And then you end up with 4/18. And you can, of course, simplify that down. Divide the numerator and denominator by 2, and you'll be at 2/9. Now, this is half of b, or half of the coefficient of x. So now we're going to square that. So we're going to take 2/9, and we're going to square it. And don't forget, when you square a fraction, you have to square both the numerator and the denominator. So 2 times 2 in the numerator gives you 4. Or I'm sorry, 2 squared, also 2 times 2, but coincidentally. And then 9 times 9 gives you 81. And then we're going to factor it. Does anyone have a question before I factor it? All right. All right, so let's factor. I'm going to bring this trinomial back down here, or it's a binomial. We're going to make it a trinomial. X squared plus 4/9 x. And I'm going to take this value where I took half the middle term and squared it, and I'm going to add it on to create a trinomial. Sorry, I'm all over the place here. I'm going to try to make a barrier. And then to factor this, we're going to use our variable to the first power. Whatever sign comes behind the variable, we're going to use. I know in the formula, technically you had a plus sign here. That could be a minus sign. Depends on what you have in your data. So if you want, you can switch that out to a plus or minus, because we are going to see some examples of minus signs. And then we have a plus. And then don't use the value that you squared. Just use half of x's coefficient, which is 2/9. And don't use 4/18 because it's not simplified. And square the quantity. And that is your perfect square trinomial, both in expanded and factored form. All right, so if you're wondering what the heck does this have to do with solving quadratic equations, well, you're about to find out, because we're going to use the method of completing the square to solve quadratic equations. In order to solve quadratic equations by completing the square, so we have to do something a little bit different here that you normally wouldn't do for a quadratic equation. A lot of times people think about getting all the terms to one side and getting 0 on the other side. When you are solving a quadratic equation by completing the square, you're trying to get to the point where you're going to be using the square root property. To use the square root property, you want to have a constant on the other side of the equation. So that's why we're going to leave that constant on the right-hand side. Now, if it's not already on the right-hand side, you're going to want to put it there. So we're going to have to move it for number 7. For number 6, it's already on the right-hand side, so we're going to let it be. So what we're going to do is we're going to create a perfect square trinomial. I want to get a quantity on the left that looks something like this, some sort of expression in x that's being squared. Once I get that, then I can use the square root property. I just have to get there. Right now, I don't have a quantity being squared where I can take the square root on both sides. So we have to make it look like the problems on the first page. So let's first create our perfect square trinomial. In order to do that, we're going to take half of the coefficient of x, and we're going to square it. So we're going to take half of 8, or you can take 8 and divide it by 2, and square it. 8 divided by 2 is 4. 4 squared is 16. And this is what we're going to add to both sides. Maybe I'll turn that on. Yikes. It was getting super dark, but that might have made it worse. Just do that. Okay. All right. Now, I say add it to both sides of the equation because in this case, we have an equation. Up here, we were just dealing with expressions. It didn't matter that the sides were balanced. But right now, I have an equation. And remember, what you do to one side of the equation, you must do to both sides of the equation. Otherwise, they're not equal any longer. So we had an expression that was equal. In order to keep it equal, we have to do the same thing on both sides. So we're going to rewrite this as x squared plus 8x plus 16 equals 7 plus 16. So I'm adding that 16 to both sides. Now we're so close already to having this in the form that we need to use the square root property. In order to do that, I need to make this expression on the left a perfect square trinomial, or a quantity being squared. So I'm going to factor this using the same steps that we did in these two preceding problems. I'm going to take the variable to the first power. I'm going to use the sign that follows my variable. And then I'm going to take half of the middle term's coefficient, not half of the coefficient squared, half of the coefficient. And then I'm going to square that quantity. So here we're just factoring that perfect square trinomial. If you're not sure whether you did it right, FOIL it out again and make sure you get back what you started with. On the right-hand side, 7 plus 16 is 23. Does anyone have questions so far? Okay. I hope you guys don't hear my dog going crazy. Clearly my family left again and he's like beside himself. It's so embarrassing. All right, if we have no questions, let's proceed. We now have an equation that's set up to use the square root property. So we're going to take the square root on both sides. When I take the square root on the left-hand side, I'm just getting that quantity to pop out of the parentheses. On the right-hand side, I'm going to apply a plus or minus, and then take the square root. I'm going to turn on a light because it's getting super dark. Now the only thing we have left to do is solve for x by subtracting 4 on both sides of the equation. And there is your solution. Sometimes students are like, wait, don't you want me to put this in my calculator as -4 plus the square root of 23 and give you a decimal? No, please don't give me a decimal ever. I want the exact answer. And I'm even going to note that this is exact. On your test, I'm going to specify to give me exact answers, not some sort of decimal approximation. Whenever you're dealing with answers that have radicals in them that can't be simplified, just let them be. Now, in saying that sentence, I just realized that you are going to have to deal with simplifying radicals, which some of you have not done in a while. So we're going to get to a point where I'm going to remind you how to do that. Because if your radical is not simplified, then you won't be able to answer correctly some of these problems. So let's do number 7. And then before we go, I'll just stop with the square root, not the square root property, completing the square. But I also wanted to talk about how to simplify radicals. So let's do this example. We'll see how long it takes, and then we'll talk about simplifying radicals so you guys can get a good start on that homework. All right, so right now we have x squared plus 4x minus 9 equals 0. Oh, someone wants to see the dog? No. He doesn't climb upstairs and I'm upstairs. Sorry, he's weird. He's 4 years old and he's a lab and he won't climb upstairs. His name is Cooper. I'll show you a picture next time. You guys are funny. Okay. Next time. But I'm not going to carry him up the stairs. So not happening. All right. X squared plus 4x minus 9 equals 0. Remember with the last example that we did, we put the constant on the right-hand side. We're going to do the same thing here. If we want to solve using the square root property, we must have a constant on the right-hand side. So move that over now. Otherwise, you're going to get confused about where to put it. You're going to get stuck. X squared plus 4x equals 9. And, you know, it should, but be really careful about these little tiny things you do. Occasionally, I've seen people put the wrong sign on this number, and that screws up the whole rest of their problem. Little things. It's always the little things. Be careful of the little things. Let's go ahead and complete the square on the left-hand side. We'll do this by taking half of the coefficient of x and squaring it. Half of 4 is 2. 2 squared is 4. This is a quantity that you're going to see quite a bit. When you want to turn this into a trinomial, you're going to get x squared plus 4x plus 4. So we're adding this to both sides. So I showed adding it to the left. Make sure you also add it to the right. What you do to one side, you must do to the other side. Questions so far? Non-dog related questions. Okay. Let's go ahead then and turn the left-hand side into a perfect square. Well, we're going to factor the perfect square trinomial. We're going to take the variable to the first power. We're going to keep the sign that follows the variable, and then we're going to take half of the middle term's coefficient and square the quantity. Remember that you can always check this by foiling it back out and verifying that you get what you started with. And then 9 plus 4 is 13. And now we have an equation that looks very similar to one we did on the first page, where we were using the square root property to solve a quadratic equation. So we've just put it into that form. Go ahead and take the square root on both sides. Don't forget your plus or minus. You have x plus 2 equals plus or minus the square root of 13. And then x equals negative 2 plus or minus the square root of 13. This is exact. Leave it. Don't give me decimal approximations. Oh my gosh. You know, he usually tries to take the dog everywhere we go, but my husband trying to juggle 3 toddlers and a dog it's a lot even for him. So clearly did not happen. Okay, we're going to do this last example next time because I want to make sure I have enough time to talk to you about, oh yeah, and there's a little bit of a different procedure for number 8. I want to talk to you guys about simplifying radicals. If you want to try number 8 on your own before next time, that's fine. I'm not going to assign any problems like this for your homework that's due Monday. The reason is the difference between 8 and 6 and 7 is that 6 and 7 had 1x squared and 1x squared. 8 is different because 8 has 5x squared. And I know that seems like big deal. What's the big deal? It makes your solution process different. So I certainly don't want to race through that at the end of class, but I do want to remind you of how to simplify radicals. So I'll assign problems like this starting Monday. I am going to assign for tonight problems from 1-1 and then anything we've covered so far from 1-5. As far as simplifying radicals is concerned, maybe I'll just work on the back of this sheet. I didn't actually prepare anything. I was just going to give you some quick examples to remind you of how to do this. Okay, I'm going to call it review, simplifying radicals. If you enter a radical that's not simplified as part of your answer, my math lab is going to give you the canned feedback that says, although your answer is equivalent to the correct answer, it's not written in the correct form. And you're going to get so tired of seeing that box and you're just going to want to, I don't know, you're going to get angry. So I want to make sure that we know how to simplify these radicals. Let's say, for instance, that you are looking at something like the square root of 12. The square root of 12 is not simplified. The reason is the 12 has a perfect square factor. What I mean by that is that you can break up 12 into 2 different factors, 4 and 3. So you can also break up the square root of 12 into the square root of 4 times the square root of 3. Now, the square root of 4 can be simplified down to an integer. Because of that, you can rewrite the square root of 12 as 2 times the square root of 3. This is the simplified version. If you enter an answer like the square root of 12, you're not going to get counted points for it. It's going to give you the canned feedback. Make sure you're simplifying that. Now, that being said, you also have to make sure that you break this number down into two factors such that one of them is a perfect square. We can also rewrite 12 as the square root of 2 times the square root of 6, but it's not going to get you anywhere. The square root of 2 you can't simplify. You can't think of a number. It's such that when you multiply an integer by itself, it gets you 2. 6 is the same way. I can't find an integer such that when I multiply it by itself, I get 6. So if you break it up and you can't figure out how to simplify it, make sure that one of those factors is a perfect square. I also want to caution you to making sure that you pick the largest perfect square factor. One problem that tends to give students problems is the square root of 32. When students look at the square root of 32, they tend to say, oh, 4 is a perfect square and 4 is a factor. So they split up 32 into 4 times 8. And then they say, okay, I know that the square root of 4 is 2. And they write it as 2 times the square root of 8. And then they wonder, why is this still not being accepted? Well, the problem is that 8 still contains perfect square factors. 8 can be further broken down into the square root of 4 times the square root of 2. So this is not simplified. You have to go further. So if you get something like this and you're still not simplified, think about whether or not it still has perfect square factors. You can rewrite this as 2 times the square root of 2. And that simplifies down to 4 times the square root of 2. This is how you would simplify the square root of 32. Now, one way that you can get around that is by saying that you can rewrite the square root of 32, instead of using 4 and 8, use 16 and 2. That will get you there much faster. So what you're really going for is finding the largest perfect square factor. So that's my very mini tutorial on simplifying radicals. I got a question on the chat. Are we going to get the homework through the student email? No. You go onto my math lab. Oh gosh, you guys are answering each other's questions. This is actually really productive. Yes, you go onto our My Math Lab course, and on D2L, if you watch the video from Monday, you can see directions on how to get on there. But the homework will be posted. I still have to put up homework from 1.5, but I believe starting at 7:40, the 1.1 homework should be up there, but I'll double check. All of the homework up there, the orientation, the 1.1 assignment, and whatever I assign from 1.5, which will be square root property and the beginning of solving by completing the square, will be due on Monday. I'm also going to give you a very short quiz on Monday that I'll put on D2L. So remember those quizzes that we're going to have on Mondays, those like 5-minute quizzes. It's going to be probably one question, and it's going to be right at the beginning of class. But I'm going to send you an email with details so that everyone is sure. Since it's at the beginning of class, I don't want there to be all this like, all this confusion of where are we supposed to go, what are we supposed to do. So I'm going to send an email to make sure that everybody knows exactly what's happening with the quiz on Monday. It's probably just going to be one question unless I can find a really short other question to put on there. I just wanted to be quick just to make sure everybody is keeping up with the work. All right, so your homework is due Monday at 6 p.m., right before class. And then you'll have a very, very short quiz that I'm going to put on D2L and I'll send out instructions for. All right, I'm over by like 1 minute, which is fine. If you have other questions, I'll be on for another 15 minutes. Please stick around. I'm so glad that I got to see you all tonight. I wish that I could see you in a real classroom, but since I can't, at least I get to see you on a monitor, and that makes me happy. Have a wonderful weekend, and please do email me with questions. I'm trying to get back to them really quickly for you because I know it's hard when you're sitting around waiting for a response. So I'm trying to get back to everybody as quick as I can. But have a good weekend and stick around if you have questions.